the fan which pushes the other 90% of the air out the back of the engine, creating thrust. Despite burning less fuel, 4 of them can propel a fully laden 747-8 at over 1,000 kilometers per hour. Just one of these engines creates as much thrust as all 8 engines on a B-52. Back at the factory, it's time to hang the engines. Massive concrete blocks hang on the wings where the engines will go. Without them, the aeroplane would tip back on its tail. Each engine weighs 7 tons, and there are 4 engines to get off their trolleys and onto the wings. That's like hanging 4 bull elephants. It's a job to do slowly and carefully.
Let me put a little tension on it and test it.
If the 4 winches are slightly misaligned, it won't go in square, and they're in trouble.
45. Got your wheels where you want them?
Our team's a pretty tight unit. We work together fairly well. We all have our positions on the plane that we like.
0.
All right, start pulling your pins. Yep. We communicate well together this way. Keeps us from getting into any troubles. Harness up for safety.
For safety.
We're about 12 inches away. We're going to pull the bolts from the front fitting. There's a pin up front that lines up the forward mount. So we lube that up with anti-seize. We'll come up another 6 inches, make sure everything is clear. Then we'll come up the last 6 inches and then put all 4 bolts in. Very close tolerance, within a 1,000th of an inch. Come on up.
It only takes 8 bolts to hang these massive engines.
All 4 started, all grabbing.
Here you go, 50%?
Not yet. I'm still getting these down, Axel.
Okay. The torque on those bolts are 625 foot-pounds on the rear, 375 foot-pounds on the front. The fronts are designed to shear off. That's per design, and that's in case there is any problems that the engine will shear at the front, fall back, and break away from the plane without taking out wings or flaps or any of that. There's one.
There are 3 more engines to mount. Once again, the crew will need to burn the midnight oil to get the job done. After weeks of painstaking work, it's almost time to switch the beast on. But first, there's more painstaking work. Every circuit needs to be checked, one by one. This plane uses a lot of electricity, enough to power over 50 households. 214 kilometers of wiring runs through the aircraft. It all converges in the electronics bay. It's the plane's nervous system. The new fly-by-wire technology is controlled by onboard computers. But it's not totally automated. The pilot can override the computer. And there are multiple layers of backup if something should go wrong.
If I were to lower the flaps, it takes hydraulic systems to do that. But if for some reason the hydraulics were unavailable, we could use the air or pneumatic air pressure to lower the flaps. If that was unavailable, we could use electricity to lower the flaps. So there's multiple layers of redundancy.
Technicians use a special computer to send a test signal to every single circuit.
Second rigger 10495. On.
Okay, Kilo 2.
Bravo 24 and Bravo 21.
Off.
The moment of truth. Time to plug in the factory power supply and fire her up for the first time. Power on is a key moment in completing a Dash 8. With engines in place, this jumbo is almost ready to take to the skies. But first, she needs an interior. Like the GEnx engines and wings, her new interior is borrowed from her little sister, the Dreamliner. There's new colours, more space, and mood lighting. Boeing customers have their own idea of interior design. Each wants their jumbo painted in their colours, inside and out. In the mega factory's huge paint shop, the green protective vinyl is washed off. A base layer is sprayed on by hand, followed by several coats of colour, depending on the customer's livery. They need to be careful with the number of layers they apply. Too much paint could mask telltale signs of metal fatigue. And besides, the extra weight of more paint would only increase fuel consumption. A typical paint job uses 500 kilos of paint. It will last 4 years. This one is painted in Boeing's own colours because it's time to put her through her paces. She must undergo a series of grueling test flights before delivery. Test pilots push the plane to extremes that will never be endured by its passengers, unless they work for Boeing. Just putting away the hand luggage won't be enough for this flight. These Boeing engineers have to tie everything down, from their lunch to their laptop.
If you don't have it clamped down, things fly in the air.
And it'll literally go straight up to the ceiling, and it can come down and hit you on the head.
The flight load survey is one of the most grueling tests for the plane, and for those on board. A strong stomach comes in handy. It might look like fun, but it's serious business. The flight load survey tests weight loads across the plane. The pilots perform extreme maneuvers, pitching the plane up, then down, going from 0 gravity to 2 Gs in seconds, stressing the fuselage and the wings.
It's great fun for them for the first couple of minutes, but imagine that we do this for several hours at a time. Sooner or later, maybe it's not such great fun anymore.
During these tests, the weight distribution of the plane is controlled using water. The pilots and engineers can pump water through barrels to shift weight along the fuselage. This simulates various load configurations the plane might encounter when it's in service.
At the forward center of gravity, aft center of gravity, heavyweight, lightweight, we need to be sure that over the entire range of operating envelope of the airplane that the characteristics are good.
Next, the Dash 8 faces the grueling velocity minimum unstick test. Test pilots try to take off as slowly as possible. This forces the tail to scrape the runway. To pass the test, the plane must safely lift off at this speed.
If a pilot were to inadvertently abuse a takeoff and the tail were to strike the ground before takeoff, that the airplane can still lift off safely in that attitude. And so when we do that, we attach a long wooden block on the tail so that we'll drag the tail on the ground, and we don't damage the skin of the airplane that way.
Next, they put this new jet through the flutter test. Flutter is the aviation word for vibration. This test pushes fly-by-wire control to the limit.
It's all high speed, generally above the ordinary envelope that we let airline pilots operate the aircraft at. And we vibrate each of the axes of the airplane by quite literally kicking the controls one at a time to watch how the controls react and make sure that the airplane, in fact, damps the vibration out to a quiet and smooth ending in a very quick fashion.
Now it's time to slam on the brakes in mid-air and see what happens.
Airline pilots typically are trained how to recover from an approach to a stall, but rarely, if ever, actually see an aircraft in a stalled state. We see it all the time. We've done hundreds and hundreds of stalls on just this model of airplane, and they're really quite benign.
A stall is when a plane's nose rises too high. The wings then stop generating lift, and the plane begins to fall from the sky.
I just release back pressure on the column and let it migrate towards the center, and sometimes I just drop my hands to my sides. The airplane recovers just fine all by itself.
Thousands of workers have put together 6 million parts to form this one aircraft. She's conquered everything the test pilots could throw at her. She's survived manufacturing delays and deadlines. For just $333 million, you can have a brand new Boeing 747-8 all of your own. The new Jumbo is ready to take on the ultimate test. Competition in the skies.
I would tell new pilots of the 747-8 to be excited. This is a wonderful machine.
But I think this 747-8 will be the airplane that it will be the airplane for the next 20 years.
The world's biggest building, this mega factory, is delivering its 3,381st aircraft. She's a little bit late, but worth the wait. The brand new 747-8 is ready to reclaim her title as Queen of the Skies.